Hello students, we will see one numerical where you need to calculate the frequency at which the polar plot intersect imaginary axis. Okay, so before solving we will see the concept here. Okay, see here, this is the polar plot. Okay, so for this transfer function you can check that two real poles are there and no pole is at origin. So this is an example of type 0 order 2. Okay, so this is an example of type 0 order 2. Okay, so we know that when type 0 system is there, so root locus polar plot will start with 0 degree line. Okay, so this is 0 degree line. So this will be first point at omega is equal to 0. Okay, and as two poles are there, so total angle contribution it will be minus 180 degree. So the polar plot will end at minus 180 degree line. Okay, so here I have shown the polar plot that is ending at minus 180 degree line. Okay, now see what you have to calculate in this numerical. You have to calculate frequency at which polar plot intersect imaginary axis. Okay, frequency at which polar plot intersect imaginary axis. So this is imaginary axis, that is j omega axis. Okay, so you can check that here polar plot is intersecting imaginary axis here. So we have to calculate this point. Here I have written the answer, but in this numerical you need to calculate this frequency omega. Okay, and second you have to calculate, look at this, when you will draw the line from this intersection point of polar plot with imaginary axis, you need to calculate this distance up to minus 180 degree line. Okay, so generally this term is referred as the gain margin and phase margin. Okay, so see here, actually we will calculate these two things. Here we will calculate the frequency at which polar plot is intersecting imaginary axis, and we will calculate this amplitude, or I will I will calculate the distance from this intersection point up to minus 180 degree line. Okay, so see what I did here. Here actually for g of j omega the transfer function is given. Look at this. I have substituted s is equal to j omega in this. Okay, I have rearranged that transfer function. 1 plus j omega by 2, 1 plus j omega by 2, so 6, that will get cancelled. Okay, now next for polar plot we know that we need to calculate magnitude and angle. So magnitude of this will be under root of 1 square plus omega by 2 the whole square. Magnitude of this term will be under root of this square plus omega by 3 the whole square. Okay, what about angle? Look at this. Here actually angle will be 0 in numerator, and when you will transfer the angle in denominator to numerator, it will be minus sign. So look at this, minus tan inverse of b by a, so omega by 2 by 1. Okay, minus tan inverse of omega by 3. Okay, so this will be angle of j omega. Okay, so here I have taken 2 points, that is starting point and end point, because I know that this is type 0 order 2 system. So the polar plot will be like this. Polar plot will start with 0 degree line and it will end at minus 180 degree line. Okay, so this is actually the polar plot. Now see what I did to calculate the frequency at which polar plot is intersecting with imaginary axis. What I did, I have rationalized this equation. Okay, see here 1 plus j omega by 2, 1 plus j omega by 3 is there. So I have multiplied and divided with 1 minus j omega by 2 and 1 minus j omega by 3. You can check here. Here I have taken 1 minus j omega by 2, 1 minus j omega by 3, 1 minus j omega by 2, 1 minus j omega by 3. Okay, so I have multiplied and divided this equation. Okay, now see what I did after multiplication. See, I have simplified this equation. Okay, so I got this equation as 1 minus j omega by 3, 1 minus j omega by 2 minus omega square by 6 and this numerator and this denominator. Okay, so purpose of solving or simplifying this equation is to take the real part and imaginary part separately. Okay, because we know that when we are talking about this imaginary part, so I need to take imaginary part separately, and when I need to calculate amplitude, so I need to take magnitude part separately. Okay, for that I have just simplified this equation. Now look at this, what I did here, I have taken the real part separately and imaginary part separately. See here j omega by 3 minus j omega by 2, these two imaginary terms are there. So I have taken j omega common with negative sign, and this will be 1 by 3 plus 1 by 2. You can check, and denominator is as it is. Okay, so I have just simplified that equation to get real part and imaginary part separately. So look at this, this will be the real part, okay, including denominator, and this will be the imaginary part. Okay, so what I did, just to get a magnitude, please remember, when we want to calculate magnitude, so I have equated the real part to 0. Okay, so look at this, equating real part to 0. So see here, I have considered only real part. So 1 minus omega square by 6 upon this denominator is equal to 0. So this denominator will get cancelled, and I will get only one term, that is 1 minus omega square by 6. Okay, so 1 minus omega square by 6 equal to 0. I have equated, I got omega is equal to root 6. But what is this omega is equal to root 6? This is the frequency, this will be in radian. Okay, this is the frequency at which, look at this is the frequency at which polar plot will intersect this imaginary axis. So we have calculated the frequency at which polar plot intersecting imaginary axis. Now next we need to calculate this amplitude, that is magnitude. For that what I did, see here, I have substituted omega is equal to root 6 in g of j omega. This is equation, I have substituted omega is equal to root 6 here. Okay, you can check that when I will put here omega square is equal to 6. So this will get cancelled, 1 minus 1, it will be 0. Okay, so I will get only the imaginary part, and just look at this, I have considered only imaginary part, and after solving, see, after solving this term, I am getting g of j omega as minus j root 6 by 5. Okay, you can cross check, you can simplify this equation, you will get the same answer. Okay, so g of j omega I got minus j root 6 by 5. Okay, so when I will take the amplitude, or I will say mod of j omega, it will be under root of a square plus b square. Okay, so here real part is 0, so what we need to take, under root of b square. Okay, so what is b? B is actually root 6 by 5. So under root of b square I will get root 6 by 5 only. Okay, so see here I got mod of j omega, that is m, magnitude. Okay, so root 6 by 5. So next actually I need to calculate angle. Okay, so look at this, I told you that here I have calculated the frequency, that frequency is actually root 6. But I need to calculate the angle at which the polar plot is intersecting this imaginary axis. Okay, from this you can check that when I am saying the imaginary axis, so polar plot will either intersect at minus 90 degree or it will intersect at plus 90 degree. But here we have to prove that polar plot is intersecting at minus 90 degree, because this polar plot shows that it is intersecting at minus 90, but we will cross check whether we are getting that angle as minus 90 or not. Okay, so for that what I did here, actually from this equation, look at this, I have taken the angle. So tan inverse of b by a I have taken. Okay, then I have substituted omega is equal to root 6 here. Look at this, so I got phi is equal to minus tan inverse of infinity. So tan inverse of infinity, actually after solving this I am getting infinity. So look at this, here actually phi is equal to minus 90. So what is this angle? This is the angle at which the polar plot is intersecting imaginary axis. So it shows that it is minus 90 degree. Okay, so I hope you are getting this. Numerical is taken just to calculate the frequency at which polar plot is intersecting imaginary axis, and to calculate the amplitude from the point of intersection of polar plot with imaginary axis and the minus 180 degree line. Okay, thank you students.